So now let's move on to imbalanced datasets and how to handle them. An imbalanced dataset has a majority class that is way more than the others, and this causes a model to poorly predict the minority class and reduces the accuracy score. So let's load our diabetes data frame to further explain this. Then we're going to call our diabetes.csv data frame. Then let's look at our diabetes data frame. And you see the diagnosis is our target, and it has two classes, which is yes or no. No to show that someone doesn't have diabetes, and yes that someone does has diabetes based on these features. So now let's see the distribution of the two classes, which is yes or no. So diabetes.diagnosis, and we want to see the value counts. And you see we have 97 people that don't have diabetes and 31 people that does have diabetes. Some data frames are highly imbalanced. Sometimes you would see like 400 no's and only 31 yeses. And that is highly imbalanced. You will get a very low accuracy score. So we should balance out that data. So let's move on to doing that. But first we have to separate the people that do not have diabetes and the people that have diabetes. So let's create two variables. Diabetes_1, and the 1 means yes that the person has diabetes, and we set that equal to the diabetes.diagnosis is equals to yes, and the next variable we're going to call it no diabetes, and we set that equal to, let me just copy and paste this. And we want a no here. And let's print the shape of both data frames. So I'm going to print diabetes_1.shape. Next I'm going to print diabetes_0.shape. Oh, it's no diabetes. Now let's run that. And you see we have 31 rows and 11 columns for the people that have diabetes, and we have 97 rows and 11 columns for the individuals that do not have diabetes. So we're gonna do a method called undersampling, and we will make a sample data set that contains a similar distribution of diabetes and no diabetes. So let me call this variable no diabetes sample 0. I just like to put the 0 to let me know that it's the people that don't have diabetes. And then we want this variable. Then we're going to use the sample, and the parameter is take n equals 31. So from the 97, it's going to take 31 random samples from it. So now let's look at the no diabetes sample shape. Control C, Control V dot shape. Let's run that. And you see we took 31 samples from the no diabetes. Let's look at the data frame itself. And you see we have 31 samples where the diagnosis is all no. Let me bring back the shape so it doesn't take too much space. So now let's concatenate the no diabetes sample with the diabetes one. So we're gonna concatenate the 31 random sample from here with the 31 rows that has diabetes. So we're gonna call it name our variable new dataset. Set that equals to pd.concat. And then we want this one. We want to concat this. Control V. Then we want this diabetes one. Control C. Control V to paste. Then we want to set the axis to equal 0. And that means that we're concatenating along the rows, meaning it will be, the no sample will be above the rows that have diabetes. And now let's look at the new data set shape. Let's run that, and it's 62. So we added the no diabetes sample and the diabetes, which gives us 62 rows and 11 columns. Let's look at the new data set. Dot head So let me do 62, run that. Oh, it's gonna give us a summary. But here you see we have the first 5 is all the no's, the last 5 is all the yes. So now we have evenly distributed data set for the 2 classes. When we use this data set for our machine learning model, we'll get better results. So next, let's move on to data standardization. And let me add a heading here. And data standardization is the process of standardizing the data to a common format or common range. This can also improve the model performance and it avoids biases. And this means it prevents the model from being biased towards features with larger numeric ranges. So let's use a breast cancer dataset from sklearn. So let me import the libraries. So from sklearn.preprocessing, I want to import the standard scaler. Then import sklearn datasets. And before we standardize our data, we have to split it in training and test sets. So from sklearn.model_selection, we're gonna import train test split. And let's run that. Next, we have to load the dataset. So data equals the sklearn dataset, and then we're gonna load the breast cancer. Now let's look at the data. Okay, it's datasets with an S. Let's run that. And the breast cancer dataset, it comes like this, but we need to put it in a pandas data frame. So this is the data or all the features, and this is the target. And the feature names should be here somewhere. Like here we have the target name that shows breast cancer is malignant or benign. And we should have the column name somewhere here, or the feature names, and here it is. So let's import it into a data frame, and for now we'll only load the features. The data frame equals pd.dataframe. We want the data to be data. The columns will be the data.feature names, which is up here. This is all the feature names. And now let's look at our data set or our data frame. And here we changed it to a pandas data frame. And we don't need to standardize Y or the targets, because it's just malignant and benign. Yes, malignant and benign. And if we had to change this to a number for our machine learning models, malignant would be 0, benign would be 1. So like I said, we need to split the data into training sets before standardization. So let's do that. I will explain it once I'm done typing it out. Then the Y train, then the Y test, and set that equal to train test split. And we want to split, well, before we do that, separate X and Y. So I'm going to move this cell above and set X equals to our data frame, and then Y equals to the data.target, which is the malignant and benign, which is this right here, all these values, the 0s and the 1. So train test splits, and the parameters it takes is our X and Y. And then we set the test size, size to equals. So in train test split, we split the data into training and test sets. So we have to put it like this because our function train test split will split the data into training and test sets. This test size means that how much data do we want in the test set. And we want 0.2, which means that 20% of the data will go in the test set and 80% will go in the train set for training. So the 80% of the data is going to get trained, and we'll use the test sets to make prediction and also evaluate our model. But we won't do this in this lesson. We're just going to focus on standardizing the data. So let me print the X shape. Actually, let me put it in print. Print X shape. X train shape and X test shape. And let's run that. And you see the X shape is our total data frame. The X train is the 80% of our data frame, and the X test is 20%. If you want the data to be split the same as mine, set the random underscore state, and we could set that to 42. For future references, when we're working on machine learning models, if you want to see the same values or you want the data to be split the same way as I am doing here, we can set it to 42. So now let's standardize the data. But first, let me print the standard deviation of the data. So standard deviation data.std, which means standard deviation. And let's run that. And you see we have a high standard deviation of 228. And if the data set is in the same range, then the standard deviation should be 1 or close to 1. So next, let's initiate our standard scalar. So set a variable called scalar equals standard scalar. And next we need to fit our X train. This is the flow we have to do. We have to split it in training sets and test sets and standardize the training sets. So now let's run that. So now let's create a new variable called xtrain standardize and set that equal to scalar dot transform, and we want to transform the X train. And now let's look at our X train standardize. Let's run that, and you see it grouped our, and you see it puts our values in the same range. So now that it did that, we would get better results. I didn't run this cell with the random state, so you're probably getting different values than me. So let's run this, run this, run this, and then run this cell. And if you're following along, then you're probably getting the same values. So next, let's standardize the testing or the X test. Control C, Control V. Let's change all these to test. And let's run that. And you see we standardize the test sets. Let's check the standard deviation of both of these. So I'm gonna print first the X train, Control C, Control V the pace, dot the standard deviation. Then I'm gonna copy this and then just change this to the test. And let's run that. So for the X train, we get a standard deviation of 1, which means that it's in the same range. And for the X test, we get a standard deviation of 0.96, which is close to 1, which means our data set is also in the same range. So for the X test, it's not 1, but it's close to 1. And it's way better than 228, which we got up here. So to clarify, the reasons to standardize the data is that it ensures all the features contribute equally by putting them on the same scale. It improves the model accuracy and also the training speed, and it ensures a more consistent model performance across different data sets.